Alrighty, good afternoon everybody. Welcome back to a discrete math. Plan for today is to give you all a few minutes to kind of talk to each other about these other proof types, this last packet I passed out last class, and then we are going to do presentations based on that packet. Got office hours today right after class, tomorrow from 10 to 11 and from 1 to 2. And you got 2 homework assignments for Friday. First of all, first 2 proof portfolio problems are going to be due. And second of all, I want you to read 2.1 through 2.2. Throwing a lot at you for Friday, but those 2 sections of the book are fairly short. We're starting Friday, we are going to be moving on to our second major topic after logic and proof writing, which is going to be set theory. So a couple comments on proof portfolio write-ups. As a reminder, these I'm not going to be giving you grades on. These are just your opportunity to submit kind of rough drafts of your proofs to me that you would like me to give some feedback on. That being said, give me your best shot. Make them as good as, make them strong. I would like to see good proofs. As far as format for these, I'm going to have a lot to say about format for the final proof portfolio at the end of the semester, but for these sort of drafts, you can handwrite them if you want, you can type them if you want, turn them in however you want. Yes, Omar.
So for each individual entry, that's just doing one of the problems on the back of the worksheet?
Correct. So basically, when I give you proof portfolio problems, I'm asking you to turn in 2 problems from the back of the worksheets. And keep in mind that as far as what we've done so far that you could possibly turn in for Friday, direct proof, proof by contrapositive, proof by contradiction. All are going to be things that you have to submit a proof of for your proof portfolio. And one thing I guess I would like you to do as part of your submission for Friday is to indicate which of the things you're submitting it as a proof for. So it's a proof of, if you want to submit something as for a proof by contrapositive, mark it as such. Yes?
And we can use those proofs on the back of the existence and uniqueness worksheet as problems for the direct.
You can use those as for direct proof because they don't really have a category, so I'll just lump them in with direct proof.
Okay.
Do we need like both a proof by contrapositive and a proof by contradiction?
You better believe it.
Okay, so those are our first 2 proofs that we have to do.
I'm not going to say like you have to do those 2 specifically.
You mean like by the end of the portfolio?
By the end of the portfolio, you will need one of everything that's in the syllabus.
Okay, I just wasn't sure if you meant by this, like this Friday, it was both the contrapositive and the contradiction.
This Friday, I would like you to have 2 turned in, and it's probably going to be out of 2 out of direct, contrapositive, and contradiction, because those are the 3 things we've talked about so far. But which 2 out of those 3 is up to you. Is there questions or comments? Okay, Griffin, I know you still had a presentation from last time that we didn't quite get to. We're not going to do it quite yet. I'm just going to lump them in with the rest of today's presentations at the end of class, I think. But in the meantime, I'd like to give you all, let's say, the next 15 minutes to talk to each other about your work on the new proof packet. The other types, the direct proof, proof by contrapositive, proof by contradiction. So, just like last time, go ahead and talk amongst yourselves however you would like for today.
Alex.
Adam, you seem to be, okay, yeah, good.
Yeah.
Find someone.
Kind of sad I'm only with Lily gone.
No, you're missing the rest of your posse.
Sure.
Did you get the first one? The direct? Yes.
I was actually at the table. Not draw One of mine,
Okay, so I did the.
my last entry.
Wait,
I know
this is so what I wrote is
basically like, but
you're supposing,
I just, so not
that
these
both X
for
and
it.
Y are odd. Then I said, I like,
And not A's.
Then-
But you can't prove it, 'cause it's not
Yeah, I just said.
true as well,
Like-
which makes it.
okay,
You know,
9
an
minus
odd-
7.
an odd- yeah, I don't know why
Yeah, and
It's
then I did,
also-
X.
Always,
No, it's supposed to be
That was a typo, it should say
Yeah.
even in there.
Okay.
Oh, okay, yeah,
that's.
Yeah, that's what I sent an email out about.
Show that it's,
I got so excited, I wrote out odd too many times.
Yeah. I had one of my entries wrong and so
I had to print out the new packet and it was, yes, this is supposed to be even.
And I understood,
At the end.
that can be one of my.
Very questions.
Not a sign, I just go through and like, I write down, so I just go.
last year.
I was thinking if you had,
So I had a
if you
question
made,
for you on the contrapositive, your example.
like, I
It
said,
says,
I was like
so,
2j plus 1 and then y equals 2k plus 1.
So,
And then,
running.
but here,
I guess,
the,
so that
like
equals
you,
2j
so
plus 1.
suppose that
yeah.
X is not odd.
So I did 2n plus 1.
Uh,
And then you did y as
then,
2k.
so,
Like just
and then down here, what you say is, the next
So
square must
then
be
if
a
you
multiple of
subtract
2,
2,
and
then
the
it's
square of the
Right, so not
So
because
it does
this
know by
is
contrapositive that if
Okay.
X squared is
Because then
odd,
ones would cancel out.
What did, so what did you like?
the next
So then
square
you
is
get
even.
It's X squared is odd and X is odd.
This is
Oh, that's a,
So like,
what the statement
okay, those lines are,
Okay,
oh my god,
I got
making all sorts of typos in a second.
I
Okay,
don't know what I did.
so in the sample proof at the end of, in my sample contrapositive proof, the last two lines are butchered. It should say, this is why you need to submit rough drafts of things so people catch these. The last two lines on the bottom of the contrapositive proof page should say, thus we know by contrapositive that if x squared is odd, then x must also be odd. Replace those two evens with odds in the last line.
I read that like 5 times. Yeah, we proved it was the original. I guess
yeah.
the gift problem.
I thought it was just taking this and
So it'd be,
Okay. It's like, so,
then you were saying that.
the bottom.
Yeah, good catch, Alex, sorry about that.
Yeah.
Because they're both, so like, they're both multiples of 2.
I did
Yeah,
my
means like even plus,
So this is an x
it's like plus x.
even,
Then, yeah, x, it's like plus x. And y, both multiples of 2.
we write the contrapositive and then prove that it's a true statement, which proves A to B. I tried to do it by contradiction, which also works for this, but it's.
so like, suppose the X
Yeah,
is
but
not
I'm
odd,
wrong.
then X.
Yeah, a lot of these you could do it in multiple ways.
And then you plug 2 in.
And for the proof portfolio, I am specifically to say I want you to do like one of each, but in general, going
So
forward,
X
once
is
we get out of
not
this.
odd.
Could I do the same problem twice?
No.
With a contradiction and.
So you start with like,
Okay.
not B. Holy shoot.
Because those will be very similar proofs. And
I'd be like, what did I do?
I want you to get more practice.
Want me to branch out?
For this,
So I said suppose X would be odd, I'm pretty sure.
Yeah, once we get into like next week and beyond, in general, like for proving things in class, you're welcome to use whatever gets the job done.
So you said it would be like,
I don't know.
For the portfolio,
You did.
Yeah.
It just shows that it's kind of
That's actually
positive,
even.
right?
Unless you
Yeah.
can
I'll
write
show you.
it as
What you show me?
an integer in. Then basically it's an algebraic manipulation.
I did.
Then you come with 3, that's 7x plus 9 can be written for 2 plus 1.
X equals 2n.
if A plus
What's the manager at?
Demonstrate that.
So then I got like
7x plus 9 is
7
even than
times 2n plus 9.
That's my
Yeah. That makes sense? I just said. Again, like it's a multiple of
How's it going
14
back?
plus 9.
Feels pretty good to me.
Yeah.
Yeah. I
Therefore, it's odd, not even.
I'm not sure this is.
Does that make sense?
It's like, I rewrote the 7 times 2n as 2 times 7n, so then it'd be like 2 times something, so you know that's even.
Yeah.
So even plus r.
So,
Yeah, I just did the 14.
started out by assuming we're both in.
That was so good.
A plus B.
Yeah, this last
So I was
Said
I
A,
had
B are
one too
integers.
off. I didn't know like how to read
Such
the
that
proof,
there's some
but
odd.
I really didn't know how to problem the same.
I wrote this problem like this plus b is odd.
So now we're
Then
going to
Then A is then and it's I guess like where was that taken?
It comes from the fact
So then
that
I
you're
sum
taking
A
one
plus
and
B.
adding
So-
the two positives, or
I
something greater
used
than or equal to
Q1
be
as
right.
A and
So that must be an even number.
So since
Basically what
B
you
is
said.
greater than or
And then I
equal to
got
zero,
zero.
you're adding one to get zero.
No.
That automatically applies to
That's
positive thing
multiple
plus
of
A plus
I was at
thing to get zero, the other thing has to be
Well,
negative.
that's not fair.
A and B.
Okay, so I was thinking about, yeah, I did all of this.
It's hard to
A and B
So, like,
have both B.
But so it says that when you put positive
Even,
and
it gives you.
then P is
Because
zero.
technically, if
no matter
Not
what.
prime.
So then I
You know
So
started.
then-
technically can't, I can't do that
Contradiction
with simple
statements
example,
like
but
this
it's, or you can't do zero, one to zero. But it's
Yes,
part of
like
it,
that
I
one
feel like it's part of the proof,
Apply all my primes.
showing that you
If
can
I
have
add
positive.
one, you add contradiction.
But you're right, you
This-
can't
I
actually
feel
be
like it's
zero.
really.
But I asked him about it
It's
because I was
not
like,
all of that.
I never really got everything proved.
It also allows to write even
I was
instead of.
Yeah, so I
like,
have a general
So I didn't
ideas that like
Well, you're not-
shows that there's no way to for this to be.
Why is
So
that?
I feel like there's a better way
If
to.
If P is a
But
if P is a positive,
so
it's like-
quantities are
you prove that the contradiction is true, so since the contradiction is true, it contradicts.
I basically arrived at the conclusion that one factor is an element.
Yeah, you have to exclude it. Okay, another typo on the back page of the packet, P has to be greater than 2, because on the very last page of the packet, the problem, P can't be 2,
Yeah.
because 2 works, but it doesn't work for any other prime.
Oh, wait.
There's a realization.
So, what we know from this is that any odd number squared is another odd
Prove
number.
it.
All the primes greater than 2 are odd. And so an odd plus 1 is even.
I did not refer to.
Okay.
Yeah, it tripped me up, and I was going over it.
Hard to really
Truth-
understand that.
Truth table, yeah, that's, you have to like add the words on that, and just do it and go on with things.
So he's saying.
Yeah, I did the same one as you did. Oh, yeah, you know.
If P is greater than 2,
I can eventually figure it out.
Now I have to think about. Okay. Thank you. Thank you. I should start like awarding bonus points or something for like catching mistakes, so as incentive for myself to not make them.
Or if we're doing really poorly, you can just start making a lot of mistakes to
Yeah.
curb the class.
So yeah, these kids need help.
Yeah, for every mistake you make, we get a bonus point or something, like the class collectively.
Class collectively. Okay, sure. Collect 50 bonus points and it counts as a completed proof for your portfolio or something.
That's a lot.
It needs to be a lot given how many
Like,
mistakes.
So if we get a score that's a complex number. Yeah.
Does someone have a different way of thinking about number 1?
It's like I got bonus points, yeah, but
Tell
it's
me.
not a kick.
Would you have to say that, like, could you just say it after you?
Also, don't forget, if you feel good about wanting to present any of these, don't forget to add your name to the list.
Okay, so since I'm already votes that ABs are not odd. So
How are you all
You
doing?
wouldn't have to
Good.
put, like,
that A.
all the even numbers greater than 2.
And, no, you just use the
Right.
A and B. And one of the things
Yeah, I
about
was gonna wake up today from that. I left.
is that, and you can just prove that by saying.
I was like, I turned off my alarm before to go back to bed, and I was like, yeah, I'm up. I wasn't up.
Know that feeling.
I mean, I said basically the same thing. I didn't do the, like,
No matter what time I.
maybe I should have,
Like, no
but
matter
I
what
said
time
if both A and B are even,
always
A.
ask at least 5 minutes more.
So there's
So,
like.
I've never been in a classroom.
And then I said something
I just think it's so funny.
And then I do
Consider
like
this
that
math
even worse,
mathematically,
but I still get like
Smart.
smart.
So I said, it was that A is odd or B is odd.
For the existence
And so.
packet, did anybody else do the proof?
Okay, so when I left at like
Guys,
7,
like,
so
always
I saw like
So,
6:55.
normally, I think things with proof
I remember like
means that you have to go to
turning it
directions.
off, and then like Molly felt like had to turn it off. And then we were in the car, and I
It
went
depends
off,
on
and I was
what the
like,
statement says. Like if I say if and only if, then yes. But if it's just like prove that if A then B, then it's only one direction.
Was X
Okay.
not
So-
odd, so you make it
Even if it might be true in both.
So that expression, not prime composable by negative 1 and 2. Yes.
odd number times.
Positive prime is only. Remember. I
Just help me write it.
I was gonna say, I'm sorry. What context are you asking this? Okay, I'm only add the word positive to that if you want to be.
Would come up to be odd, because it's.
Technically, -2 is prime, and -3 is prime, and -5, etc.
Wait, that's weird. I never thought about that.
Like negative numbers. I feel like in my head, though obviously I know like the language over here.
I don't
is,
know
like, the idea that
like
like
one is the
unit.
unit.
I hope you're.
But like there,
I mean, I can
no.
find that you usually give me up for morning, but I like it though.
-1 is not the unit because -1 time, it's not the case that -1 times X always gives you back X. It gives you back -X, but that's not the same. Also, if you take abstract algebra, you get to learn about how to find things that are prime that are not even numbers.
That's scary.
Yes.
Sometimes.
Are we like?
So I suppose that like.
Figure out that scary.
And then it says to win.
So like, and I understand, like, I didn't like the S here, I took it in high school.
Adding and
I guess it's gonna be a lot of
Just
answers.
one useful to write a lot of words for it.
It's like, I don't like it.
These things happen.
My biggest like complaint is that I'm like awesome, but then like it's just one thing to read it and talking, and then like you can't like
Why
hold
just
it on.
East, west,
And then
We proved that odd plus even is
I don't
odd.
know what it's like.
It's just like on the third proof.
I just didn't know there was a, or I don't know. if
I'll say this, once you get past chapter 1, so like starting Friday, you'll be able to, I'm gonna allow you to use
I already
like
took it, I'm gonna read
things
it.
you just know like that without having to prove. But for today, you have to prove that.
So you have to prove that an even plus an even isn't even.
That's not a reason.
You have to prove that kind of stuff too.
If we haven't proven it yet already this semester, then yes.
Okay.
I'll say
Yeah,
this,
it's
though,
your
for that
program,
one,
Is there
yeah.
another way to do it? That's-
see if you can find a way to rewrite this as 2 times something plus 1.
Okay. I just, thank you.
Because I think you can make a slight tweak to your
I'm
expression
like, I don't even know what I have.
to be able to get there more directly without having to prove
Those
something.
guys are Friday. Taking time to learn it.
I like it.
So it's just such a.
Last call for signups.
You got this, Alex. Alex just put his name on all of it.
Alex, I'm not choosing you if you put your name down for anything.
I think we should just do random selection for all the questions. Just assign everyone.
I mean, I kind of try to do it pseudo-randomly, but based on people who have presented less. So like Alex, for instance, has presented 3 times as opposed to a lot of the classes done twice, and he presented last class, so he's kind of at the bottom of the priority list.
Yeah, we
I didn't want to.
For now, once more students get through 3 presentations and.
I didn't want to.
I would have definitely at least.
Didn't want to do any of them though.
All right, let's see.
It's fun, I had fun with it, it was a good time. Basically try.
Which I know is like so mathematically can't do.
30, 69, that's all you gotta know. It's like all the math they have.
It feels like I proved this, and it's more satisfying for me.
Yeah, very fluid.
There.
GRE's because you're like, no, at least right. You specialize office, 20 computers.
Alrighty, and with that, I think we're going to start our presentations for today. So Griffin, you wanna do yours first?
Hi, my name is Griffin.
I don't think anybody heard you.
No, I don't think they did.
Pay attention.
I did. Yeah. My name is Griffin. I will be proving the last problem on the existence and uniqueness packet. And so the last. So the last problem says prove that there exists a unique function f of x. The unique function f of x such that f prime of x equals cosine x and f of pi over 2 equals 1. And so to start, I started with the idea of existence. And so I have considered f of x equal to sine of x. And then I just proved that that equals that f prime of x is cosine of x, and then that f of pi over 2 is 1. Yes. So that covers the existence side of the proof, and then the second side of the proof is asking about uniqueness. So for this, I introduced a g of x, and so I'm supposing that there exists both our f of x, our f of x, or our f prime of x, which equals cosine of x, but also I'm assuming there is a g of x, g prime of x, that equals the cosine of x. And then I do the same thing for f of pi over 2. And so from there, I just set these things equal to each other. I'm gonna move over here. And so we have our f prime of x is equal to cosine of x, which is equal to g prime of x. Oh. Yeah, no, that works. I was thinking about whether or not I needed to make these x's different, but I don't, because it's two different. We're showing that the functions are unique, or that the function is unique and not the variable. And then I also have f of pi over 2 is equal to 1, and which is equal to g of pi over 2. And if you want to, you can finish with f prime of x is equal to g prime of x, and f of pi over 2 is equal to g of pi over 2. So that is my proof. Are there any questions? Yes, Alex?
So how does it follow from those last two mathematical statements that f of x and g of x are the same function?
Well, this is actually something that I thought about, and I think I instinctually put f of x and g of x on a phase because we are working with trigonometric functions. They actually do repeat, like there are multiple places where they equal 1, but not where this value will give you 1. So yes, cosine of pi over 2 is equal, or sorry, sine of pi over 2 is equal to 1, just as sine of, what is that, 3 pi over 2 also equals 1. But because we have a value here that makes it unique. Did that answer your question?
What I'm saying is, like, would you need to show that if you take the antiderivative of f prime of x and g prime of x, you get the same function, and
Because you
then
could have f plus 2 and g plus 1 or whatever.
and then you use the f of pi over 2 equals g of pi over 2 to show that they're unique
Yes.
to those constants.
Yeah, I think that you need to have this plugged in value that shows that. So
Alex, would you like to write down on the board what you're what you're saying? Because I think you're making some interesting. I think you made an interesting point. I'd like to see.
yeah, that we need to connect those two. Do you have a visual way of showing?
Yeah, what I was just saying was, you would, so since we know that f prime of x equals g prime of x, you know that, let me see real quick. We know that the antiderivative of f prime of x equals some f of x plus the constant c1. And if we're going to show every step, f prime of x equals cosine of x. And so, let me see where we're going with this. And so this would be the antiderivative of cosine of x is sine plus a constant. The antiderivative of g prime of x equals, again, sine of x plus another constant, we'll call it c2. Now we know that f of pi over 2 equals 1. So we know that sine pi over 2 plus c1 equals 1, right? And we know that g of pi over 2 also equals 1. So again, by the same logic, sine of pi over 2 plus c2 equals 1.
Okay.
These are equal to 1, so if you subtract on this side, you arrive at the conclusion that c1 and c2 are the same. And thus you can conclude that f of x equals g of x.
Very good.
So,
Thank you for writing that.
Any other questions for either Griffin or Alex?
I mean, it was like, would you have to go all the way to show that they're unique, or do you just need to show that?
I had something in mind like what you did. Like, since f prime equals g prime, that implies f of x and g of x differ only by a constant. And then you can use the fact that they're the same at pi over 2 to say that that constant has to be 0, which means they're the exact same function.
All right, very good. Thank you.
Thank you. Here we go. All right, Malin is a direct proof.
Hi, I'm Madeline, and I will be doing the direct proof that states if x is odd and y is odd, then x minus y must also be even. So for my proof, I said suppose that x is odd and y is odd. Then x equals 2n plus 1 for some integer n. And y equals 2k plus 1 for some integer. Okay. Then I show this by doing x minus y equals 2n plus 1 minus 2k plus 1, which equals 2n plus 1 minus 2k plus 1, which equals 2n minus 2k. And then I said thus x and y are both multiples of 2, and thus x minus y must be even. Does anyone have any questions? Yeah.
I don't think this really affects the proof, but wouldn't the negative distribute?
Oh yeah, sorry, yeah, you're right. So those would cancel out, is that what you're?
Yeah.
Yeah, thank you.
I have a question about your conclusion. You said x and y are both multiples of 2.
Yep.
But when we started the problem, we said they were both odd, which means they would not be multiples of 2.
Well, for like, in the problem, it's that like an odd can be n equals 2k plus 1, is that what you're?
Yeah, but that wouldn't be a multiple of 2. Because you're taking multiple 2 and adding 1 to it, so it wouldn't be this by 2.
Do you mean to say that n and k are both multiples of 2?
Yeah, probably, yes. That makes sense. Thank you.
Could you also factor the 2 out, so it's like 2 times n minus k, so there's just one number that you were working with at the end instead of still saying that there are two numbers whose difference is.
Yeah, that probably work.
And I think what she's saying is clear because N and K aren't necessarily going to be multiples of 2 here because they can be anything, they're just multiplied by 2.
Right.
Or is that what you're saying? Sorry, I thought you were saying multiples, but they could be multiplied by 2. I'm looking at your conclusion.
Yeah.
N and K are just integers, which means they could be even or odd.
Right. So like, if those integers are multiplied by 2, is that what you're? It's weird. The wording's weird. Yeah.
So I think there's a question of what did Madeline actually show? She showed that x minus y has to be equal to 2n minus 2k. I don't think that necessarily shows anything about n and k individually, but what do we know about the expression 2n minus 2k?
It's gonna be even.
What?
Oh, sorry.
Well, so 2n minus 2k is even, and so that means that x minus y is even. Which is what we're trying to prove.
Yeah, I think if you erase that second to last line and just say thus x minus y must be even, I think this will be a little.
So just like erase this top line. Got it.
I don't think you could say anything about n, k, x, or y individually from that algebra, but you can say that x minus y then.
You could probably say that n minus k is an integer, I guess, if you wanted to.
You could. You could if you wanted to be real. If you wanted to be really detailed and write everything out, you absolutely could.
Okay. Any other questions?
Nice job, Mel. I especially like the beginning of your group. I thought you wrote things out very clearly.
I'm presenting the Contrapositive Proof. So we're going to try to prove that we're trying to prove let x be an integer if 7x plus 9 is even, then x is odd. And so for a proof by contrapositive, we're trying to prove that if not B, then not A. So this is A and this is B. So we're going to try to prove if x is even, then 7x plus 9 is odd. Suppose that x is not an odd integer. Then x is even. And it can be written in the form x equals 2n for some integer n. Then 7x plus 9 equals 7 times 2n plus 9, and then we can simplify that. by writing 14n plus 9. And that can be written as and then since 7n plus 4 is an integer, we can say that 7x plus 9 can be written in the form of an odd integer. And is thus not even. And thus we know by contrapositive that if 7x plus 9 is even, then x is odd. Does anyone have any questions?
Well, Laura, do you mind scooting over just a little bit so?
Sorry.
Thanks. Questions or comments for Laura? All right, nice job. Hey, good job, Laura. I thought that was a really nice contrapositive proof. Good way to show that A implies B by proving that not B implies not A. And sometimes trying to go backwards can be a lot easier with negations than going forward with this. Okay, and last up we have Helen Mariah.
Okay, I'm gonna do the proof by contradiction. So
Here states, assume A and B are both integers. I'm just gonna then if A plus B is odd, then A is odd or B is odd. Okay, so since I'm doing a proof by contradiction, I want to show that A and not B is a contradiction. And I have a helpful hint that reminds us that A and not B is the same as, that not B, since this is an or statement, we need to prove that A is even and B is even. It's changed from the or. So I started by supposing that A plus B is odd, and A is even, and B is even. And then I took these definitions and I wrote N. A equals 2N, where N is an integer. And B equals 2M, where M is an integer. And then I put those into A plus B. A plus B equals 2N plus 2M, which can be written as 2 times N plus M. And we know from this that A plus B must be an even integer because N plus M is an integer, and the definition of an even integer is that it's an integer multiplied by 2. So, thus, if A plus B is odd, then A is odd or B is odd. And then as a reminder of how the proof by contradiction worked, I just added in parentheses, but this was because if A and B are even, A plus B is even 2. Are there any questions? Holly?
I guess I don't understand quite what you mean by like A and not B, like, would that be part of the second statement, or like, I didn't, could you just sort of explain where that came from?
Yes, so this was just me writing out what I'm supposed to do when I do a proof by contradiction, is I'm assuming A and not B, and I'm showing that that can't be. So when we did the true false tables with A and B implications, A implies B is true in every circumstance except when A is true and B is false, so not B is true.
So is like the true part the odd part? So like if A is odd or B is odd, so would it be like A or B like being odd, and then you would do the truth table from
Are
that?
you talking about the upper and lower?
Yeah, I don't know.
AB or the uppercase AB?
I'm talking about like where the A or not B would like come from that sentence. Like where are you pulling those?
So let's say Helen Mariah. I'm going to answer this just because we're running a very low on time. Nice talk. I think the confusion, Holly, is that I think Helen Mariah was treating A plus B as odd as sort of her A, like capital A, and then her capital B without a negation is the statement little a is odd or little b is odd. So in essence, what she did was say that she took this sentence and wrote it in the form A implies B, and the way you can prove that by contradiction is to assume that your hypothesis is true, that A plus B is odd, and that her conclusion was false, that it was false that A is odd or B is odd, meaning A and B both have to be even. And if you assume that hypothesis and negation of your conclusion, then that leads to a contradiction. Does that make a bit more sense?
Yeah, I think so. I just kind of took the hint, like. Yeah, I think it makes sense.
Oh, the hint was just it was just a reminder of how you negate the
Yeah, and
B here.
That's kind of what I was confused about, because I like took the hint like very literally, and I didn't realize that was part of like the whole of So I think, yeah, we're good now.
Gotcha. Yeah, no, I thought this was a very nice proof. All right. The one thing I might add, just as an extra line to your proof, is just saying something here about your contradiction, because I felt like there needs to be something here saying plus A plus B is even, contradicting that we assumed A plus B is odd. But yeah, otherwise I think this proof works really nicely. And you assume that if your hypothesis is true and that the conclusion is false, then something happens which can't possibly happen, which is that little a plus b has to be both odd and even. Okay, that kind of ends the first major unit of this course, the logic and proof writing part. So starting on Friday, we're going to get into chapter 2 in the book, which deals with set theory. And it'll take us the next probably couple of weeks. And with that in mind, I hope you all have a good rest of your day.
The third state journal, is that due on Monday?